Hello, geometry. Here we go with lesson 6. And what you're going to notice is this is a little break from proofs a little bit. There is a proof that I'm going to do in these notes, but the main idea here has nothing to really do with proofs. What it is a theorem that we can use in proofs. But yeah, let's just go ahead and get started. So an isosceles triangle, you should know what this is by now. An isosceles triangle has exactly two sides congruent. Okay. Now there's a theorem associated with this. And the theorem says if two sides of a triangle are congruent, okay, so if I have that true, then the conclusion is that the angles across from those sides are also congruent. All right. So if two sides of a triangle are congruent, basically, if you have an isosceles triangle, then the angles across from the congruent sides are also congruent. So I have an isosceles triangle there, right? What I have is two sides congruent. So ST is congruent to UT. So then the angles across from those sides. And what does it mean to be across? So if I start at ST and what angle is not attached to ST? That's the one that's across from it. That's angle U. UT, what angle is not attached to it? S. So what does the theorem say? If ST is congruent to UT, those two sides are congruent, then angle S is congruent to angle U. Okay. In this particular triangle that I have here, STU, there's two different types of angles. There's vertex angles, and then there are base angles. Every isosceles triangle has one vertex angle and two base angles. The vertex angle is angle T in this case. It's the one that's between the two sides that are congruent. Okay. The other two angles are base angles. Those are the ones that are congruent. All right. All right. Notice that the isosceles triangle theorem is a conditional statement that goes all the way back to unit 2. Okay. And if then, write the converse of the isosceles triangle theorem. So I'm going to do some shorthand here. So just a little recap. That's the hypothesis. Two sides of a triangle are congruent. The conclusion is the angles across from those sides are also congruent. Okay, so if two angles of a triangle are congruent, okay, then the sides across okay, from those angles are also congruent. Okay, and that theorem right there is actually called the converse of the isosceles triangle theorem. You do need to know the difference. It's where you start. So the isosceles triangle theorem, okay, isosceles triangles are determined by their sides. So in the isosceles triangle theorem, you know the sides are congruent and you conclude the angles. In the converse, you know the angles and you conclude the sides. Okay, so you do have to do the difference. So here's another picture. Okay. Okay. So if angle P is congruent to angle Q, what can I then conclude? That's what I'm wanting you to do here. Well, what I can conclude is the sides across from those are also congruent. So let's draw a line across from P and an arrow across from Q. So that's RQ is congruent to RP. Okay. So that's the converse of the isosceles triangle theorem. Here's the proof I was talking about. Okay. First thing you want to do is good idea to plan your proof. Does it make sense to do what we've been doing and prove triangles are congruent? First of all, can I even show any two triangles are congruent here? No. What do I need to show? Well, I'm trying to prove that this is an isosceles triangle. The big overall triangle is an isosceles triangle. How do I show it's an isosceles triangle? Well, I'm gonna have to show that two sides are congruent. Okay, so I'm getting a game plan. I'm trying to get to that. So I want to show two sides are congruent. How am I going to do that? Well, let's jump in with what we're given. Well, I'm given that WV is congruent to WS, right? That's given. It's in the picture. Angle S, I'm going to mark this with a different color. Angle S is congruent to angle WVS. So that's already marked there. How do I know that those are congruent? That's the isosceles triangle theorem. Okay. I have two sides. I can conclude that the angles across from them are congruent. Therefore, they are congruent. Okay. Angle WVS is congruent to angle R. How do I know that those are congruent? Well, that was given, and we were in the picture at the beginning. Okay. Well, if angle WVS is congruent to angle S, and it's also congruent to angle R, I can use the transitive property to say that angle S is congruent to angle R. Well, if angle S is congruent to angle R, and let me go ahead and clear some stuff here. If angle S is congruent to angle R, those are two angles in the big triangle. What allows me to say that TR is congruent to TS? That would be the converse of the isosceles triangle theorem. Okay. And now I can say by the definition of isosceles triangle that this is an isosceles triangle. It's definition because I have two sides congruent. Okay. So am I going to ask you to do that? Probably not. More what you're going to see more with this lesson is what you're about to do here. Find the values of the variables. Okay. So you're going to be using these theorems a lot. Okay. In this lesson, obviously. I have two isosceles triangles. Okay. So here and here, though, that shows me that those are isosceles, which means that these two angles right here are congruent. I have another isosceles triangle, which tells me that these two angles are congruent. Notice that it doesn't necessarily mean that these are congruent to these. That does not mean that, okay? However, I do see that these are vertical angles, so they have to be equal as well. So I'm going to go ahead and add in there that those are also congruent. Okay, well, if this one over here is 65, then this one's 65, then this one's 65, and then this one is 65. So those are all 65. Okay, so how am I going to find X? Well, if I know two of them are 65, 65 plus 65 is 130. It's a triangle, so adds up to 180. X equals 50. Okay, let's do the next one. I've got, again, two isosceles triangles here. So I've got one is that triangle here, and I'm going to focus there first. These two angles are equal. So that's 70, right? That's that one right there is, oh, there we go. That one right there is also 70. Which means this angle up here is, we'll call it y. 70 plus 70 is 140. And I get y equals 40. But I want to find x. Well, x and y together make a line, right? X plus y equals 180. And I know y is 40, so subtract 40, I get x equals 140. Now, could you find that a different way? Hopefully you're realizing that yes, you could. I'm gonna go ahead and delete that, and I'm gonna show you another way. Real quick. So I know that's this angle here is 70. I also know that that's a right angle, right? So if that blue dot is 70, this red dot here has to be 20. Well, if that's 20, then that's 20 because of the isosceles triangle theorem, which says that these two angles are equal. Well, 20 plus 20 is 40. X is what's left. It's 140. Okay, so another way of getting the same answer. All right, this is a little trickier. Find the values of the variables given that the perimeter is 26. So that's going to come into play here. It doesn't help me right away though, because x plus y plus 3 plus 3y equals 26 doesn't really help me because I have two variables in there. Okay, so what am I going to do? Well, I should see that these are both 43. What does that mean? Well, if they're both 43, that means that those angles are congruent, which means the sides across from them are also congruent by the converse of isosceles triangle theorem. So I can say that x equals y plus 3. They're the same. Now I can take that and put it in for x, and I get a new equation of y plus 3 plus y plus 3 plus 3y equals 26. So now we can solve that because it's all y's. 1y, 2 y's, 5 y's. 3 plus 3 is 6. Subtract 6. You get 5y equals 20. Divide by 5, you get y equals 4. Okay. Now, how do you get x? Well, we'll go right up here. 4 plus 3 gives me x. X is 7. All right. So that's another use of your isosceles triangle theorem and its converse. A corollary is an idea that follows directly from a proven theorem or postulate. So there's a corollary that follows from the isosceles triangle theorem. Now, just to recap, isosceles triangle theorem says if two sides are congruent, then the sides across from them, or the angles across from them, are congruent. What happens if all three sides are congruent? Well, then wouldn't all three angles across from them be congruent as well? Yes, they would. So a triangle is equilateral. That means all the sides are the same. If and only if it is also equiangular, which means all the angles are the same. Notice it's biconditional, if and only if, meaning it is true in both directions. Okay, the conditional and converse are both true. So if I said I have an equiangular triangle, so all the angles are the same, then it's also equilateral. So here's the corollary in use. I have an equilateral triangle right there, right? 1, 2, 3. Those are all the same, equilateral, right? So it means they're also equiangular. So these three angles are the same as well. Let's just call them x. Well, then that's 3 x's, right? And they have to add up to 180. So I by 3, I get each angle is 60. Okay, now that's not m or n, but it gives me 60. Now I can go in and find m and n. So I'm going to go ahead and erase some of this stuff. if this is 60 and the whole thing is a 90, n is what's left. Okay, so 60 plus n has to add up to 90. N has to be 30. And then 30 plus m plus 90 has to equal 180. You should solve that and get m equals 60. Okay, so there's your isosceles triangle theorem and the corollary that goes with it. That's it. Again, not doing any proofs with this. We might be using them in proofs though.